Alright, here's your homework video on trig identities. So there are different ways to get trig values. This one we're going to use some identities to support it. So we're given that tangent beta equals root 15 over 10. So what would cotangent be? What identity would I use? And so the easiest identity is the reciprocal identity. So that tangent and cotangent are reciprocals of each other. So there's the reciprocal. You can rationalize it. You can simplify it down, and you have your answer. Cosecant and sine, what identity would you use? They are reciprocals of each other. And then have the skill, if you needed to rationalize it. This is 6 times 424, and then it goes into there 8 times. Number 3, cotangent, sine, and cosine. Well, one of the identities for cotangent is that it's cosine divided by sine. That's an identity. So if cotangent is negative a half, and sine is 2 root 5 over 5, then to get cosine by itself, I multiply both sides by that fraction. So I'm not drawing right triangles, but I am, or using the unit circle, I'm using identities, formulas that I know about trigonometry to help me. So know the 2's divide out and you get negative root 5 over 5. Next, hey, that's alpha. So secant alpha, negative 9 over 7. Tangent alpha is there. What reciprocal can I do to help me out here? So to understand it as reciprocals, if secant's negative 9 over 7, then cosine is negative 7 over 9. Tangent, by definition, is sine over cosine. Now, I can now plug in. I know to get sine theta by itself, because as soon as I know sine alpha, I should say, I just do the reciprocal to get my answer. So I would multiply both sides by cosine alpha. And cosine alpha, we just said is negative sine 7 over 9. So again, I multiplied both sides by cosine alpha, and I know what that is to get sine alpha by itself. The 7's divide out. Negative times negative makes it positive, and you get 4 root 2 over 9. Now, that's for sine. So then what would cosecant alpha be? Would be the reciprocal of that. And if we rationalize it, we just multiply by root 2, top and bottom. And then your final answer would be, that's 9 root 2 over 8. Number 5, sine theta and tangent theta. If cosine theta is negative 3/4. So one of the identities we can use here that involves sine and cosine is that sine squared plus cosine squared is equal to 1. Now in this situation, to get sine squared by itself, you would subtract cosine squared, and then you'd plug it in. So cosine is negative 3 over 4, so if I square it, it would just be negative 3 over 4 squared. So I'm going to answer that. So that's 9 over 4. I'm going to get common denominators so that I get negative 5 over 9. Oh, and then I still need to do the square root of that. Why did I say over 4? It would be 9 over 16. Ugh. So these are 16. So it would be 7 over 16. Now, I still need to square root that. So we have sine squared is equal to 7 over 16. So when I square root it, then sine theta is equal to root 7 over 4. Now, tangent theta is equal to sine over cosine. Now, notice both of them have the same denominator. So when I go root 7 over 4 and negative 3 over 4, the 4's divide out and leave me with root 7 over 3, and it's negative. So here's one answer, and here's the other answer. All right, number 6, cosine and tangent. And you're given cosecant. So first of all, I think right away that if you're given cosecant, then the reciprocal might be more helpful. That's negative 2 over root 6. And then multiplied by root 6 top and bottom and reduce it down, you get negative root 6 over 3. So I know that sine squared plus cosine squared is equal to 1. So I plugged in what sine is. Now, see if I can square this one right. That's 6 over 9. Subtract. I could reduce it down. I'll do it in a second. This is 9 over 9, get common denominator, so you get 3/9 or 1/3. Now, to that answer, I have to do the square root. So the square root of 1/3 is 1 over root 3 or root 3 over 3. Now, in this situation, I have to be aware of the other one too. You have to understand what quadrant we're in. So if all students take calculus and cotangent's positive and cosecant's negative, that means we must be in quadrant number 3. So for cosine, we just figured out cosine is root 3 over 3. It must be negative root 3 over 3 because of the quadrant that we're in, because cosine's negative in that quadrant. Oh, and tangent. So then tangents is found by dividing sine over cosine. So negative root 6 over negative root 3. So a negative divided by a negative would be positive root 2. Let's make sure I know what quadrant we're in. So it says that tangent's negative. And it says that secant's positive. So we have to be in quadrant number 4. So what do we know that can help us here? So we can do the Pythagorean theorem for also tangent and secant. So I know that tangent squared plus 1 is equal to secant squared. That's an identity, a formula. So to get tangent squared by itself, I would subtract 1 and then do the work involved. So plug it in and square it. That's 9 over 4. Take away 1, get common denominator, so it's 5 over 4. Then square root both sides. So tangent beta then is equal to root 5 over 2. And in quadrant number 4, it's going to be a negative root 5 over 2. To find cosecant, based on what we have, so I just found tangent. Now I want to find cosecant. So I know that cosine beta must be 2 over 3, and then I can use the formula sine squared plus cosine squared is equal to 1. Get sine by itself, so subtract 4 over 9, get common denominators. That should be a 9. So you get 5 over 9, and then the square root of that would be root 5 over 3. In quadrant 4, sine is negative. And then if I know sine, then I know cosecant. So what's the reciprocal of that? And then rationalize it, and you have your answer. Number 8. If you look on the answer key, they didn't answer the question. So the answer key asked for cosecant, but they just stopped at sine and didn't do the reciprocal. Number 8, cosecant, cosine, and what you're given, which is just cotangent. So where can we start to understand this? So first of all, what quadrant are we in? So if all students take calculus, if cotangent is positive, those aren't the quadrants. If secant's negative, that must be that we're in quadrant number 3. Next, there's an identity that connects cotangent and cosecant. So 1 plus cotangent squared is equal to cosecant squared. So if cotangent is 2 root 6 over 5, I can then solve for cosecant squared. So root 6 squared is 6, 2 squared is 4, so it's 6 times 4, which is 24 over 25. If I add them up, I need common denominators. So I'll use 25 over 25. So that gives me 49 over 25. So when I do the reciprocal, or sorry, when I do the square root of that, I get 7 over 5. And then know what quadrant we're in. So in quadrant 3, it's going to be negative 7 over 5. I also need to find cosine. Well, if cosecant's negative 7 over 5, that means sine must be negative 5 over 7. So we can go negative 5 over 7 squared plus cosine squared is equal to 1. Subtract, so this is 25 over 49, so subtract 25 over 49, get common denominators. That's 49. So 49 take away 25. Is that 24 over 49? Square root. And then it's equal to the square root of 24 over 7. Again, it's going to be negative there. And then you could also write that as 2 root 6 over 7. Again, in the answer key, they don't write it as a negative answer, but we know it's in quadrant number 3, so cosine is negative. All right, good news. I'm not going to ask you about these even-odd identities. So you are done at question number 8. So good job doing your homework. Mr. G Math. Over now.